Okay, so let's go over just the basic symbol for these. Just this is kind of what you need to know for tomorrow, the very minimum. Okay, so length. Length is, you've got, this one has got lots of symbols because you've got all of this stuff. All right, so the most obvious one is length. That would be just, I suggest you use a lowercase l, not a capital L. You can if you want, but capital L's can get kind of messy. Either one's correct though. All right, now let's look up here. Displacement. Displacement has two symbols, actually technically three, but you can do, of course, delta x or delta y. Either one's fine, you know. Hopefully you understand that concept. Or displacement, like official symbol, remember, is an S with an arrow. Not seconds, it's different. These are apples. Hopefully this looks like a different color that I'm writing in. And I want its arrow to stay, and it won't stay. Okay, so then let's look at distance. Do not use the letter D. Some people do. That's not, I mean, that's just not our convention in our class. So I want you to think of distance as the magnitude of displacement. Distance is displacement without direction. Since displacement's a vector, vectors commit crime with direction and magnitude, whatever. So you would just write displacement just like you just did, and then this looks like the absolute value sign, but remember in physics, it means just magnitude. It means there is no direction. It's like you're blocking that arrow from doing anything useful. Okay, also height, really simple. Yeah, height, I know it can have whatever direction, but you don't really see, I don't know, we don't put it on that. Anyway, so height, h, you know, it's just one of those weird things, like all the different ways to spell different stuff, like red in English, but whatever. Okay, and then radius. Now, a word of advice, I did this with some classes. If you write your R's like you down, then up, this starts to look like a V really fast, like that's your R. So I suggest some people don't write their R's, some people do this on their R's or something. If you do that, that's fine. But just to be careful, I suggest, and I always do this, capital R. That's the better safe than sorry is your capital R. So all of these are your 6 apple things on the sheet, and that's what they all mean. Okay, so let's go to meters per second. This is velocity, which is of course a lowercase. If you can make it look cursive-y, that's fine. If you can't, I'm never good at that. That's your velocity. So it's V with an arrow, it's a vector. So let's do magnitude of velocity. Speed is magnitude of velocity. Remember, it's velocity. Think about your speedometer. It doesn't tell you which way you're going. So just block in that arrow. That's it. Velocity, speed. Okay, so acceleration doesn't have a fancy name for the magnitude of it, and really in this class we're just dealing with the magnitude, but well, kind of. Acceleration is just A with an arrow. Okay, so now let's go to force. That is an easy one. For this particular one, you don't have to write the sigma, which means net. That's just when you add all your forces together, like, you know, free body diagram thing. So it's just F, capital F with an arrow. Work and energy. Now this one, work is pretty easy. That's W. Capital W, my capital W's kind of look weird. W is work. You got lots of different kinds of energy. The ones we talked about is potential. Remember the potential to hurt you, capital U. And what can cause potential energy? You know, think about a bowling ball being held over your head. Well, that's potential energy due to gravity, measured in joules, as is work. Or gravitational potential energy. Gravitational, it keeps erasing. That says gravitational potential energy. Well, what if it's caused by a spring, like a giant slingshot or something that I'm holding over your head? Well, that would be potential energy caused by a spring. I'm pointing to this subscript. These are just little subscripts down here. Okay. So, and then what if the energy is moving? Then it's capital K. And that's kinetic energy. And remember, if you had mechanical energy, which I didn't put on here, that's just your potential energy, or all of your potential energies plus all of your kinetic energy. So, but that one's not super important. I just want to point that out. Also, up here, I meant to say on force. You know what's the force that you deal with the most? I'll give you a hint. It's the one that points straight down. The first thing you write with a free body diagram. Oh yeah, that's your mass times acceleration due to gravity. Because that can also be G. That's like the gravitational field, how you're getting pulled down to the center of like a planet or Earth or Death Star or whatever. So yeah, these, same deal, that's your weight. Don't use a W, don't use FW, do that. Okay, then this is watt, and we'll get to that later. But this is the main Apple portion of everything, parts you should kind of already know.